Hey everybody. Okay, so in today's class there were some questions about even and odd functions. And when I kind of go back and I look at it, I'm thinking, those are really good questions, you guys. Because this is one of those things that I know about. I don't have it memorized per se. I have it memorized when I'm teaching it and I reviewed it. But let's say that I haven't looked at this in a really long time, and I'm trying to prove that something's even or odd. Now, you might be going, I don't even remember what even and odd is. Okay, so I always think about really basic functions. So if I think about this, it's an even function because it's x squared. Now, you're probably going, wait a second. It was not that easy in pre-calc. You're right, it wasn't. Because once we start adding things on here, that changes things up where they might not be, even or odd anymore. But I know the basic ones. If there's nothing added or subtracted, there's nothing in the argument, that's an even function, that's an odd function, okay? And even and odd, well, we'll just stick with polynomials. Okay, so I know that, and I know what the graph of this function looks like. Okay, now this is the part when I told you guys that don't focus on answer getting at this level. I want you to focus on really making sure you understand why something works. I'm going to give you a story that I asked my son. This is years ago. We were trying to figure out how long students that were in AP classes, how long they were spending on homework. And he had Mr. Mason back then, and I asked him, and he's really smart. He went to MIT, so he gets math. And I said, well, how long are you spending on your calculus homework per night? Because Mr. Mason didn't know, and he asked me to ask Mikey. And he was like, about 2 hours. I think I can't remember exactly. But I was like, okay, 2 hours. So I could tell Mr. Mason that the average calculus kid spends 2 hours a night on homework. And he started laughing. And he said, no, they don't spend 2 hours. I'm like, well, how long do you think they spend? I said, oh, you're really good at math, so that it's hard for them, so they spend 3 hours? And he was like, no, they maybe spend a half hour or 45 minutes. And I was like confused. And I was like, well, what do you mean? And he goes, oh, they don't get that they don't get it. And I didn't understand what he meant. And what he meant was that he studied everything to the point of totally understanding why it works, not just using a formula, not just getting an answer, okay? And that's something I want you to try to do. And it's hard, okay? And it takes time, but the more you do it, the better you get at it. Okay, so I want you to think about this graph. Okay, I know that the point 2, 4 is on that graph. And it also has the point -2, 4. Okay, I know this is an even function, and I can just look at it, so I know it's symmetric to the y-axis. So again, when I forget that, I just draw that little picture, and that reminds me. And this is going to be important in calculus because we're going to see that we're going to do some pretty complicated things. And we don't want to necessarily work with both sides of this because that's just too much work. And we'll be able to go, oh, let's just work with one side. We know it's symmetric to the y-axis, and then we can double things. So lines of symmetry are going to be very important. Okay, so now I want you to think about this in a different way. So I want you to think about this is x, and this is f of x. Okay, so remember, that's always true, the x and the y. Well, technically, in terms of this is -x. And this is f of -x. Okay, so again, that's one of those things you have to think about. Like, why does it work? Okay, so if something is even, what is always true, I can turn that into a coordinate, is that if the graph has x and f of x on it, it will also have -x and f of -x. Now, it's not enough, if you had to prove this, it's not enough just to show that. Like, you can't just say, oh, well, look, it has 2, 4 and negative 2, 4. Therefore, it's an even function symmetric to the y-axis. You can't do that because maybe it has those two, but the other ones don't work. So in order to prove, what you have to do is you have to show that that and that are equal. And look at right here. See how they're equal to each other? Okay, so you have to show that f of x equals f of negative x. Okay, so there's a way to do that. Okay, so what I'm going to do is I'm going to find f of negative x. Now, when you're doing a proof, even though you know that that is x squared, you're proving it to me. So even though you know it in your head, that's not a proof. You can't go, you know what I meant. That doesn't work, okay? So you have to show that step. Notice where these parentheses are. It doesn't mean if I wrote it like this, okay, let me put it somewhere else. Okay, this right here is not the same thing. Why did I put F? I should have put Y. Okay, is not the same thing as that. Okay, be very careful. This is one of those things that younger students totally blow off. And it's very important that you go, this is saying take the opposite of x and square it. This is saying take the opposite of x squared. They mean two totally different things. Okay, so you got to watch where those parentheses are. That's important. You would lose points if those parentheses were not there. Okay, so f of negative x, well, I know that a negative x squared is x squared. Okay, is f of negative x equal to f of x? Well, let's see. We said that f of x was that. We said that was our original equation. I got that from right here. Yeah, so those are the same. And on a proof, you always make a conclusion. So I'm going to say, since f of x is equal to f of negative x, the function is even. Okay, so don't forget that a proof always has a conclusion. Okay, now let's go back and let's look at y equals x cubed. Okay, so this is a function that I have memorized. And I can just think about, I know the point 2, 8 is on this function, and I know the point negative 2, negative 8. Okay, so if this is x, this is f of x. So in terms of this, if x is 2, then this is negative x, and this is f of negative x. Okay, so it's not the same as this proof right here. Here I was trying to show that f of x and f of negative x would be the same exact number. Here, I want to show that f of x and negative f of x are the same number. Okay, so this is kind of weird because I have to think about that is the opposite of that. Negative 8 is the opposite of 8. Okay, oh, wait, let's talk about symmetry. Most people think even and odd are symmetric to the x and the y-axis, and they're not. Functions in general, there's only one function that's symmetric to the x-axis, and that's the equation of the x-axis, y equals 0. But symmetry to the x-axis, not a function. Okay, so this is symmetric to the origin. And if you're going, how do you know that? I can think about like if I could rotate this around, like if I had like a little pin right here and I could rotate that function around, that this piece would end up on that piece. I also know that when things are symmetric to the origin, that if it has this point here, it has to have this point here. Okay, so I know that if it has x and f of x on it, it's also going to have negative x and f of negative x. Okay, so this is that part that comes into the thinking thing, like it takes time. Okay, so these aren't equal to each other, right? This right here is the opposite of that right there. This is the opposite of f of x. Okay, so to prove, so this is kind of weird, you have to show that f of x is the opposite, or equals the opposite of f of x. So that equals the opposite of negative 8. Well, the opposite of negative 8 is 8. Okay? And actually, I want to say f of negative x is what I should have said. Okay, did I just mess you guys up? Okay, I want you to show that if you put in a negative x, the thing you get out right here is the opposite of what you got out here. Okay, I know that I probably could have said that better, but I'm not going to redo this whole thing. Okay, so let's look at how we would prove. So you have to show me f of negative x. And again, I'm not going to assume just because I know the answer. I'm proving it. So I'm going to show that. Well, a negative x cubed is going to be a negative x cubed. Okay. Now, the opposite of f of x. Again, even though I know you can do this in your head, well, I guess in this case, there's not really anything to show. But you kind of want to show that. And then the opposite is that. Okay, see how these two are the same? So you're going to say, since f of negative x equals negative f of x, the function is odd. Okay, so make sure that you get that down. Okay, so let's hope that that's enough to get you through those ones. That, now you understand it. Again, take some time with this. Draw the pictures. Make sure it makes sense to you. That's what we want to do. Okay, so hopefully that worked. See you guys later.